Well, hello. In this video, we're going to learn how to solve system of equations by substitution. So I got you an image here. It's also on the back of your homework guide. If it's not, or you don't have that near you, there it is right there. You may have seen puzzles like this on the interwebs and various places, but this is essentially a bunch of images of fruit that are in equations. They want you to find the values of each of the fruits and then do a thing at the end. Take a minute or two, press pause, and try this problem out. Let's see if you get the right answer. Seriously, press pause. Give it a try. See you in a little bit. Okay, so hopefully you tried it, and you got the answer, 20. Did you get 20? If so, high five yourself. If not, if you weren't sure, maybe there was a little mistake, go back and look. If you're not sure what you did at all, stay tuned at the end. I'll show you how. This is a system of equations, right? It's a number of variables and a group of equations with more than one variable. Thus, it is a system of equations. And you probably solved it using substitution. And that's what we're going to learn about today. So let's get into our first example here. Our first example is going to be y is equal to 2x minus 3, and then we have x plus 3y is equal to 5. This is a system of equations, two equations grouped together, and let's talk about steps of how to solve this. Steps to solve by substitution. And the first thing I want you to do, step 1, is get a variable by itself. Get a variable by itself, and check this out. Good news. We do have a variable by itself. See how I have y by itself on the top there. So that was easy. Step 2. Step 2, we are going to plug into the other equation. So we have y by itself. We have another equation that also happens to have y. So what we're going to do is we're going to substitute for y. So we're going to use the other equation, x plus 3 times. Now instead of y though, we're going to put parentheses. Something is going to go in for y. What do you think is going to go in for y? Well, it turns out it's what y is also equal to. Y is also 2x minus 3 from the first equation. So we plug it in to the other equation, right? We got a variable by itself. We plugged it into the other equation. Step 3, I bet you could see where this is going. We're going to solve. So, first thing we got to do here to solve this is distribute. X plus, we're going to distribute and get 6x minus 9. Oops, that's a bad 9. Is equal to 5. Combine like terms. X plus 6x is 7x minus 9 is equal to 5. We're going to add 9 to both sides. If you need to add 9, go ahead. But I'm just going to... 7x is equal to 14. And finally, the last step, x is equal to 2. X is equal to 2. Great! X is 2, Smith. So what? Well, that's what's next. Next thing is we're going to... So now that we have x is equal to 2, we're going to plug that into the original. Into the original equation. Now, the original equation was this y. So we have y is equal to 2x minus 3, but here's the thing. Wait a second. I'm going to back up. Instead of 2x minus 3, it's going to be 2 times something minus 3. Because guess what? We know what x is. X is 2. Oops. So I'm going to plug in 2 for x, because that's what we found from this original thing. Go ahead and solve again. Oops. So we have y is equal to 4 minus 3, which is 1. And that brings us to our final step. We're going to write the answer as an ordered pair. write the answer as an ordered pair. So that means our final answer here is going to be the 2. Remember, it goes x, y, so it's be 2, comma 1. The reason why we're writing it as an ordered pair is because remember from last week, if we were to graph this is a line, this is another line, it's just in standard form. The intersection point is the solution, and that's the ordered pair. All right, so this one was easy because step 1 was done for us. Get a variable by itself. I'm gonna use my. Let's do another example. Example 2. We have x minus y is equal to 3. And we have x plus 2y is equal to negative 6. So this one, step 1 was to get a variable by itself. In this case, nothing's by itself. We have to figure out a way to get a variable by itself. Now, the easiest variables to get by itself are ones similar to the types of people that I think most of us would want to date, right? They should be positive single variables, just like positive single people. Anywho, positive single variables. Top x is positive and single. Top y is negative. That thing's a bummer. I don't want to play with that one. Bottom x is positive and single, but bottom y is, there's a 2 in front of it. It's not single. It's positive, but it's not single. I'm going to go for top x. I'm going to get top x by itself, and the way that I would do that is I would add y, so we have x equals 3 plus y. You see what I did here? I added y to get it on to this side. I have x is equal to 3 plus y. With me on that? All right, so now we have a variable by itself, and we're going to substitute that into the other equation here, the bottom equation. So that's going to be something plus 2y is equal to negative 6. See how I'm taking the bottom equation? I'm going to substitute x. What's going in for x? Right here, right? The 3 plus y. 3 plus y is going in for x. Now you combine like terms and solve this. There's nothing to distribute here. I just put parentheses just to show you that what's going in for x. Then we solve this. We have 3. What's y plus 2y? 3 plus 3y is equal to negative 6. Subtract 3. 3y is equal to negative 9. What is y? Y is equal to negative 3. Great. So we got a variable by itself. We plugged it into the other equation. We solved. Now we need to take this value and plug it back into the original. Now, when I say the original, it can be either be the first one that they gave us or the other version of it that we created. Now, assuming I did this right, I'm going to go with this one because look at this. X, all we have to do is find x. This one, x is aching to find out what it is. So take this guy, and we have x equals 3 plus whatever y is. In this case, y was negative 3. So what's 3 plus negative 3? 3 plus negative 3, of course, is 0. So then, we write our final answer as an ordered pair. We got the point 0, comma, negative 3. How could you check that answer? Remember, the way you could check it is plug it in. It needs to work for both equations. If it only works for one, it's not a solution. So check this out. 0 minus negative 3. What's 0 minus negative 3? Well, that's positive 3, just like it is at the beginning. And then we have 0 plus 2 times negative 3 is negative 6. Look at that. It works for both of them. Checked out on top, checked out the bottom, so that is our solution. And we give you one more if you want to try this. Actually, there's 2 more. But if you want to try this one by yourself, negative 2x plus 4y is equal to 0. Let me get an example. And then I got 3x plus y is equal to negative 7. If you want to try it by yourself, go ahead and press pause, try it out, and I'll walk you through it at the end. Otherwise, you can follow along with me. Here we go. Remember, we got to get a variable by itself. Which one is the easiest to get by itself? Top x. Again, it's not positive and single. Think about it. I'd have to subtract 4y and then divide by 2. That was not terrible. Top y is not positive single, not positive and single. But I think the easiest one is that y. Get bottom y by itself. Y is equal to, you would subtract 3x on both sides to get this one. So it would be negative 7 minus 3x. Get a variable by itself. Once you have a variable by itself, you're going to take this and plug it in to the other equation. So we're going to plug it in for y here. So that means we have negative 2x plus 4 times something else is going in for y is equal to 0. What's going in for y? This stuff here. The negative 7 minus 3x. Alright, distribute, combine like terms, and solve. So, got negative 2x minus 28 from distributing minus 12x is equal to 0. Negative 2x minus 12x is negative 14x minus 28 is equal to 0. Add the 28 to that side, so you got negative 14x equals 28. What is x? X is negative 2. Great. So we got x. So what? And we got to plug this into the other equation. Or into the original, I should say. So it'll be y is equal to negative 7 minus 3 times something. What's going in for x? Negative 2. And we have y is equal to negative 7 plus 6. Is everybody cool with that? Look at this. Negative 3 times negative 2 is positive 6. So negative 7 plus 6 is... Oops. I got that in the wrong color. Sorry, y'all. Negative 7 plus 6 is y is equal to negative 1. So our final answer is negative 2 comma negative 1. Tell you what, I got one more problem for you. Copy this down. The sum of two numbers is 17. 4 times a small number plus 2 times a large number is 46. Find the two numbers. Tell you what, first thing you need to do is you got to write an equation. Go ahead and press pause and write an equation. I'll meet you back in just a second. Hopefully you got this. Now, you got to pick a variable to get by itself. Either, I think our two most likely candidates are either the top S or the top L. In this case, I'm going to go for the top S. So I'm going to say S is equal to 17 minus L. Hey, take a minute, try and finish this. I'm going to do it here, check back. Let's see if we agree. Go ahead and press pause and hook it up. So I substituted S into the other equation. Got L is equal to 11. That means that the small number is 17 minus 11. So the small number is 6. Now, since this is a word problem, writing it as an ordered pair isn't really appropriate here. It's not really... It asks us a question, so we're going to answer the question. The large number is 11, and the small is 6. If it's a word problem, answer the question. If it's just a straight up problem, go ahead and just write the final answer as in ordered pair. I promise you to, I told you that I'd show you the original in this video. I'm out of time, so if you've got questions, go ahead and ask them in class. Smith out!